folks, welcome back to Physics with Captain Rod. I'm making this video here to be just a quick crash course on the difference between DC circuits and AC circuits, and a little bit about how to work AC circuit problems. So over on the left, over here, what we're looking at is kind of a simple circuit diagram for a standard DC source. This symbol represents the battery, or the voltage of the battery, with the long terminal as the positive, the small terminal is the negative. The assumed positive current direction in this picture would be clockwise, and we have some sort of resistor here. So this is referred to as a DC voltage, which stands for direct voltage, and the big deal is that the voltage does not change polarity or direction. The current as defined by positive charge carriers will be clockwise in this picture the entire time. If we were to graph voltage against time, it would be relatively constant within the fact of like the battery might discharge or things like this. But the big deal is it's not going to reverse direction. It's not going to do something like this. Now, like equations, like what do we apply here across the resistor? We would use things like Ohm's law, voltage equals current times resistance. And to calculate the power, that's current times voltage, also equal to I squared R when you combine these two equations. Right, so now, let me chat a little bit about AC voltages now. So with an AC voltage source, this would be coming from an electrical generator. So this circle with this squiggly thing is the symbol for an AC voltage source. And let me chat down here first. So your typical AC voltage source follows a sine wave in nature. It looks like this. It has a max value in both directions. I'll put minus V max here at the bottom. And half the time you'll notice the voltage is in one direction, and half the time it's negative, meaning it's in the other direction, and it goes back and forth. There's a time frame. I'm going to put this in the graph. From here to here is the time to complete one cycle. That's called the period. And there's what's called the frequency, which is 1 over the period. Now, what does this mean? Well, notice that the voltages here, they're in one direction, let's say positive, and that might correlate to current clockwise in this picture. But then the other half of the time, the voltages are negative, correlating to a current counterclockwise in the picture. So as a result of this, the current is going to be half the time in one direction, half the time in the other. Whereas over here, the current was always clockwise. Now, this max voltage, okay? The max voltage is not what's important whenever you do voltage calculations. You want to use what's called the average voltage, or it's actually called the RMS voltage. And you get the RMS voltage by taking your peak voltage, or your max, and dividing it by the square root of 2. I'm going to save the reason for another video. This is meant to be just a quick conceptual thing, but here's where this is coming from. The RMS voltage is the theoretical DC voltage that has the same power as the AC voltage. For a standard US power grid, the input voltage has a peak of about 170 volts, meaning that on this graph right here, we get up to 170 and down to minus 170. And it has a frequency of 60 hertz, meaning that this time here for one complete cycle is 1/60th of a second. The RMS voltage you get by taking the maximum and dividing by the square root of 2, and you're going to get a number approximately 120 volts. Now, as far as working these AC circuit problems, at this level in the class that you folks are in, if you're watching this video here, you're going to be using the same equations as you would for a DC voltage problem. Voltage equals current times resistance. It's kind of standard to use a small I for AC currents as opposed to a capital I for DC currents. Power is current times voltage, or current squared times resistance. But here's the big kicker. These equations are all good, but you must use the RMS voltage, VRMS. So as far as working your problems, you're probably in maybe my Physics 109 class or maybe one of the other introductory classes. If you're talking about just an AC source hooked to a resistor, all the equations that you're familiar with from DC circuits, like Ohm's law and how power is calculated, they're all still valid. You just have to make sure you use the RMS voltage instead of the maximum or peak voltage. If you're dealing with the US power grid, your peak is typically 170, your average is 120 volts, and your frequency is 60 hertz. This probably will not show up in any of the problems that you have to do. It's typically not a factor until you add other elements to the circuit, such as capacitors and inductors. So again, that's AC circuit difference between AC and DC, and how to work AC circuit problems, at least when an AC source is hooked to a resistor. Again, crash course in 5 minutes or less. I've got many more videos in the works about more of the details. So I hope that this helps. Have a great day.